Hello, everyone. This is our physical science class on Wednesday. And today we're going to be talking about what makes an atom an atom. So, in the last class, we talked some about Dalton and his atomic theories. And we talked about how one of the things that Dalton talked about was that in, say, a piece of gold, all of the gold atoms are the same, right? And in a piece of silver, all of the silver atoms are the same. So today what we're going to talk about is what makes a gold atom a gold atom? Why is it gold? And what about a carbon atom? Why is that carbon? What about oxygen? What about helium? What is it about an atom that makes it what it is? So the thing that makes an atom what it is the number of protons. So if you remember, the model of an atom is that we have a nucleus and there's protons in the nucleus and then there's electrons spinning around the outside of it. Okay? So what makes an atom is the number of protons, how many protons there are in the middle there. And the number of protons is what's called the atomic number. Okay? So the atomic number is the number of protons. Now on page 103 of your book is a picture of a periodic table. So if you look at all of the various things on the periodic table, what you'll see is a box that looks like that, sort of. And let's take carbon. Carbon has a big C in the middle of it. And then up on top, it has a 6, okay? This number, I'll just write it in. Underneath it, it has a 12, okay? You're not going to worry about this 12 right now. That's thankfully not something you have to worry about yet. You probably will eventually. But for right now, we're just going to concentrate on the top number. This top number, is the atomic number. So the number that's on top in the periodic table, that's the number of protons that are in a carbon atom. Okay? Now, one thing that we can know also is that if there are 6 protons in a carbon atom, there's going to be 6 electrons. There has to be. Because in nature, everything wants its positives and its negatives to be balanced. So the number of protons equals the number of electrons. Okay? Okay. So far we've got the number of protons in an atom is its atomic number. And that is what tells you what that atom is. And the number of protons always equals the number of electrons. So in carbon has 6 protons. So that means carbon has to also have 6 electrons. Okay? All right. Now, we'd learned about that there was something else. So in the nucleus of an atom, there's also something else besides just protons. There's something called neutrons, okay? And neutrons are neutral. So the number of those can be kind of different. So we know the number of protons has to equal the number of electrons so that the charges balance out. But the number of neutrons, that doesn't matter as much because those don't add any charge. All they add is mass. Okay? So the number of electrons can vary. And we have a name for that. When the same element has a different number of neutrons in the nucleus, they're called isotopes. Okay? Isotopes. So, here's an example of isotopes. If we look at our periodic table, let's go back to page, what did I say that was on? Page 103. Let's look at hydrogen, okay? So on the periodic table, hydrogen is the top most left element. It's in a red box and it has an H in it. Okay, so it looks like this. It's got a box, it has an H, and on the top it has a 1. And then underneath it has 1.01. Okay, we're not going to worry about what the bottom means right now. We're just going to look at the 1. So this 1 on top, remember what that is? What's that? That's the atomic number. And the atomic number is the number of protons. Okay? So hydrogen has 1 proton. So if hydrogen has 1 proton, how many electrons does it have? It has 1 electron. I can't hear you if you're trying to answer me, so I'm just going to answer it myself. All right, so hydrogen has to have 1 proton and 1 electron, and that makes it hydrogen. Okay, simple enough. But if you were to go out in nature, if you had the capabilities to do this, you could potentially collect 3 different kinds of hydrogen, all right? So you could collect hydrogen, and I'm just going to draw a plus because there's just 1 proton in there. And then here's, whoa, that looks weird, but all right, there's the electron flying around outside. You're going to find 3 different types of hydrogen. You're going to find, I'm going to put an N here. You might not be able to see that. That's an N for a neutron. You're going to find hydrogen that has 1 proton and no neutrons. You're going to find hydrogen that has 1 proton and 1 neutron. And then you're going to find hydrogen that has 1 proton and 2 neutrons. Okay? They're all hydrogen. Okay? All these 3 things are hydrogen. They're not a different element. They're all still hydrogen because they have 1 proton and 1 electron. The number of neutrons doesn't matter for what element it is. So these are all isotopes, okay? They are isotopes of hydrogen. And they tell you in the book their names. This one is protium, this one is deuterium, and this one is tritium. Thankfully, I don't think you have to memorize those. Tritium, this one over here, is radioactive. It's something that I actually used to use when I worked in a lab. You sometimes use something radioactive so you can track where it goes through a cell. But anyway, it's radioactive, but you don't have to worry about that. What you do need to worry about is that these are all hydrogen because they have 1 proton and 1 electron, and they are isotopes of one another because they have a different number of neutrons. Okay? Okay. Now, the book talks about one other thing. This other thing that we need to know and understand is something called a mass number. Okay, so remember the atomic number, that's written really bad. The atomic number is this number up here at the top in the periodic table, and that's the number of protons. And remember, the number of protons will always equal the number of electrons, okay? The mass number is actually the number of protons plus the number of neutrons. Okay? Why is that important? Because protons and neutrons both have mass. So that's going to change how much that atom is going to weigh, whether it has neutrons. So just looking at these three hydrogens, this hydrogen has 1 neutron, and this hydrogen has 2 neutrons. So this is going to be the lightest hydrogen. This one is going to be the middle-sized hydrogen, and this one is going to be the heaviest hydrogen. In fact, sometimes when you use tritium in a lab, you just call it that. You call it heavy hydrogen. It's heavier because it has 2 neutrons in it. So the mass number of this hydrogen is going to be 1. It has 1 proton. That's it. The mass number of this hydrogen is going to be 2 because it has 1 proton and 1 neutron. And the mass number of this hydrogen is going to be 3 because it has 1 proton and 2 neutrons. Okay? So the mass number, now make sure you remember the mass number, do not add the number of electrons into the mass number. The reason why is because electrons don't really weigh anything. I mean, they weigh something because they exist, but they don't weigh enough to make a difference. So we don't worry about the mass of the electrons. So electrons do not factor into mass number. Mass number is just the number of protons plus the number of neutrons, okay? So let's take a look at the 2 examples in the book on page 93. So example 3.1. All atoms that make up the element nitrogen have 7 protons. Where does that tell you nitrogen falls on the periodic table? That tells you there's going to be a little 7 up here, okay? Anyway, if a particular nitrogen atom has 8 neutrons, what is its name? Oops, I forgot to do names. Sorry about that. Okay, we need to go back and talk about what we name isotopes. So we name isotopes based on the mass number. The mass number, not the atomic number. We name them based on the mass number, okay? So, remember how we said this one has a mass number of 1 because it just has protons. So this one's name is going to be hydrogen. Oops, I didn't spell it right. Hydrogen 1. And that's a dash. It's hard to read because I can't write very well here. Hydrogen dash 1. This one, because the mass number is 2, it has 1 proton and 1 neutron. This will be hydrogen 2. And this last one over here is going to be hydrogen 3 because its mass number is 3. Okay? So we name isotopes based on their mass number, not their atomic number, and it has nothing to do with how many electrons they have. So you don't name them based on electrons. Make sure you remember that, okay? Okay, so let's go back to our example now that I've taught you how to name these things. All right, so I'm going to erase the board so I can write this example on the board. So hold on a second. Okay, so all atoms that make up the element nitrogen have 7 protons. If a particular nitrogen atom has 8 neutrons, what is its name? Okay, remember we name them based on the mass number. Ugh, can't write today. Mass number. And remember, the mass number is the number of protons plus the number of neutrons. Okay? So, in this example, this nitrogen has 7 protons plus 8 neutrons. So it has a mass number of 15. So its name is going to be nitrogen-15. Okay? That's how you do those. Now, the next example says, which of the following atoms is an isotope of nitrogen-15? Okay, let's remember what isotopes are. They have the same number of protons and a different number of electrons. Okay? So what we need to do is look down this list and find another one with the same number of protons. There were 7 protons, so we need to find another one that has 7 protons. So the first one said, for letter A, it says 5 protons, 5 electrons, and 10 neutrons. Nope, that's not going to be an isotope because it doesn't have the right number of protons. Letter B, 8 protons. Nope. Letter C, 8 protons. Nope. Letter D, 7 protons, 7 electrons, 7 neutrons. Yes, letter D is going to be the isotope of nitrogen-15. Then they ask, what is its name? Okay, remember, its name has to do with the mass number. So in letter D, it has 7 protons plus 7 neutrons. And we ignore those 7 electrons. Those don't get added in because electrons don't weigh very much, basically nothing, okay? So we just do the number of protons plus the number of neutrons, and that gives us 14. So the name of this isotope is nitrogen-14. Okay? All right. Hopefully you all understand that. So now you can go back and do the big spiral workbook. Do whatever it says in there to do for today. All right. Bye.